Hey fellow YouTubers, this is N0AGI. Here's part 3 of the Raspberry Pi FARM-2 cluster build out. In this part 3 we are going to cover the software components of building out the cluster. In part 2 we looked at how we built this, so if you haven't watched that, please do watch part 1 and 2 so you have some context behind this part 3. So we completed the hardware portion of the cluster in part 2, and in part 3 we'll talk about getting the image ready into the SD card, and then making sure we have every component ready to go on the software side of it. So most of this video will be spent on SSHing into this station. This is another Raspberry Pi station. So I'm going to use one of these SD cards and burn Raspbian from the raspberrypi.org site, and then start with that basic image, get that going on this station, and I will start adding additional software components to it and some basic default settings to it. And then once I have the image ready, I will replicate that SD card into the other two SD cards and go from there. Okay, so step number 1 is take one of your 16 gigs. 8 gigs capacity SD card should work, but if you have a 16 gigs SD card, I think it's better. But either way, just take your SD card, stick that in your PC or whichever operating system. I run Windows, so I have it on my Windows PC. And go to N0AGI.com, and then underneath my website, if you go to Web Farm Cluster menu, that should take you to this page here. Over here I tried to document as much as I can about this build out, and I included links for the parts like we discussed earlier, and I also have a link to my OneDrive where you can download the config files, templates that you can customize and use it for your own project. I think for the purpose of this part 3 video, look for the software links section and then go to Raspberry Pi Raspbian download page link. Okay, so when you click on that, you will be taken to this page here of raspberrypi.org, and what you're looking for is there are two versions of Raspbian. One is with the desktop baked into it image, and the other without the desktop, and they call it Lite. In case of our situation, at least in the examples that we are going to show here, I don't need a desktop. I want to keep it light. I want to save as much SD card space as I can. So I'm going to select Lite and just download the zip file. Okay. So download the zip file, save it to your local folder on your PC, and I've already done that. And so save it to your local PC and make sure you unzip it, and I have done it. When you unzip the zip file, it creates a .img file. Okay, so keep that handy because you will need that. Okay, and then go back to the N0AGI page and then look for the Hdd Raw Copy Tool. You can download that from hddguru.com. I've already done it and installed it, and what it does is it allows you to burn the image into your SD card as a bootable SD card for your Raspberry Pi. So after you download it, install it, run that tool, and the first step is to select your source file or the IMG file. And then the way you do that is simply double click on that and download, or rather select the img file that you had unzipped earlier, and I've already done that, and I've already selected that img file here. Okay, and then say next or continue. Step number 2 here is to select the target. Where do you want to copy this, right? You want to copy that into your SD card, and this is my SD card here. I have a 16 gigs inserted into my PC, so I'll select that. Okay, so now the process will start. Basically, click on, be sure and be aware that your SD card will be formatted at a low level, so everything will be gone. So if you need to back up or whatever, take care of that first before you proceed. So in my case, I don't really care, so I'll just go start. It gives you a warning, say yes, and it does its thing. So I'll let it finish, and I'll see you back after it's done. Okay, so the process completed. Now your SD card should be imaged out with the Raspbian stretch lite.img file. So the process here on your PC for this USB stick is complete. You can go ahead and close this tool. And what you want to do now is take your SD card and you need to insert that into one of the Raspberry Pis. You might want to hook up a monitor and a keyboard to it so that you can do some basic level configuration, and we'll go do that right now. Okay, so here is the SD card I just burned on my PC. So I'm gonna take this and I'm gonna install that onto this Raspberry Pi station like we discussed earlier. Okay, so I installed the SD card in there. I also have this keyboard. It's a wireless keyboard from Logitech, and I installed its USB dongle onto one of the Raspberry Pis here, so I can work the basic configuration with it. So if in case you have a wireless keyboard that has a mouse pad on it, it's more convenient. So this one has both the keyboard and the mouse pad. That works really well for me. You could also have just a USB keyboard and a USB mouse attached to it, and that'll work just fine. So anyway, so let's get started. What I'll do is we need to start the Raspberry Pi. Okay, after you reboot, it will put you on your login screen where you'll be asked to log in with a user ID and password. While it was rebooting, I had installed a network cable in the back of the Raspberry Pi, so I'm hoping we'll have the IP address allocated already by now. So let's log in. The first step is to log in as Pi, the default user ID. And the password for default user ID is, I believe, Raspberry. First things to do is to change the password. Okay, and I think it's important for you to change your password to whatever preference you have. So I'll do that for my station here. Password. I'll enter the current password and the new password. And again. Alright, so the password for Pi is changed. I now want to change the password for root. By default, the root account doesn't have a password, and you will need to assign one to it. So the first thing to do is to do sudo password root. And the new password for root is okay. So the password for root is also changed. So that's good news. The next thing to do is to run a tool called Raspi-Config. And the way you do that is launching it by sudo raspi-config, and that should bring you to this page. Okay, we already changed the password, so we don't need to mess with that. Let's go to hostname and hit OK. This is a default hostname. We could change this to something more meaningful to our cluster. Let's call it web farm-2, and then hit OK. Now eventually, once we move this or replicate this SD card to each of the 3 Raspberry Pis, the host name for each of those Raspberry Pis will be different. For the broker, it will be webfarm2 broker, and for the 2 workers, it'll be webfarm2 worker 1 and worker 2 respectively. So for now, we'll just leave it as a generic name like that, and we'll hit OK. Let's go into interfacing options. Now this is where you will select or enable SSH. What SSH does is it allows you to remotely manage and monitor this workstation. Working the station remotely through SSH is a much more convenient way for me, because I'd rather be in front of my other PCs and manage the station remotely than being in front of it with a keyboard and a mouse pad, and it's just painful. So let's go to SSH. And would you like the SSH server to be enabled? Yes, please. And now the SSH server is enabled. Okay, now it'll bring you back. Let's go into localization options now. Let's go into change time zone. Select US. I'm on Central Time. Okay, let's go back into localization. Change keyboard layout. And let's select a generic 101 key PC, English US. And the default is OK. And no compose key, OK. And we should be fine. Now I think we are pretty much set. I think we are in pretty good shape. Now, because we have already connected the network cable, we probably will have an IP address already hooked up or allocated. And if that is true, then we should be able to run the update option. However, we don't know yet. So let's not do update quite yet. Instead, we'll finish this off, and it'll ask you to reboot. Say yes, and that should reboot. Okay, so we are now back on the login screen. I'm going to log in as root and log in with my password. Alright, so I'm in there now. Let's see if I have an IP address. ifconfig. As you can tell, I have an IP address here, 1.1.190. Let's see if we can ping google.com. I'll have to ping bing.com. Yes, of course. Alright, so that's working. So it looks like we have internet connectivity. We are in pretty good shape. I just want to do one last command on this station, and my next steps will be through SSH. And that last command will be to go apt get update to make sure we get the latest updates from Raspberry Pi to apply any system level updates to this station. Alright, looks like we are in good shape. So for now, I think we are good. I just want to confirm one last thing actually. I want to make sure that the SSH service is running. And indeed it is running, right? And that should be pretty good. Alright, so let's be done here, and I'm gonna log out from this station, and my next stop here is to go back to my other PC and SSH into this PC. and I'll pick you up from there. I'll be right back. Okay, so the next step is to go back into my website here. Go to N0AGI.com, go into Web Farm Cluster, look for the software links section, and look for the terminal tools. There are many options out there, and people have used or people still use PuTTY quite a bit, and it's a very popular tool, and I used it a lot. And it's a quite a simple tool, not too many bells and whistles. It does have quite a bit of functionality compared to other tools, but still it's quite simple. I really like the MOBA Xterm tool. It gives you the ability to manage multiple SSH terminals in one single UI. And given that I have about 14 or 15 stations I manage through SSH, I really like MOBA Xterm's flexibility that way. So I'm going to use MOBA Xterm for this demo. So if you haven't downloaded this already, go ahead and download it. And I've already downloaded and installed on my PC. And I also already have some sessions on my PC, on my terminal set up already. For us to make the next step, go into this many options session, and let's create a new session. Now, a new session can be a variety of things. There's so many options. But what we are really interested in is the SSH session. Let's select that. Let's go into the Raspberry Pi, which is 1.1.1.190, and default is Pi, and the default port is 22. Hit OK. And then it takes you right there to the, it pulls up a new window and takes you right there to your Pi. And right now, it should normally ask you for a password, because it should bring you into a login window and should ask you for a password. And I think it will when you do this. And I made some changes earlier, so it's probably remembering my previous settings. So anyway, so that's that. So go into your terminal, and what you want to do is there are a couple of features with terminal. I think just quickly, one of the features I really like is the follow terminal folder. If you could check that box, and then go here and say cd/etc/ssh d, I believe, or SSH. And if you do that, this pane here automatically refreshes with whatever the content is on that folder. So, which is pretty cool, because now you're able to edit these files using your local text editor, whatever your choice be. Let's say we want to edit sshd_config. All right. Typically, what you would do is go nano sshd_config. Let's do a sudo. All right. Now this pulls up the built-in Nano editor, which is fine. It's it's just bare bones editor, which works pretty okay. But I'm used to using a desktop style editor that's already installed in my PC. So I rather, instead of editing the file on the terminal, I rather, if I can type, I'd rather go here and say, hey, you know what, I want to edit this file, right click, open with default program. And then let's say I use Sublime Text as an example. All right, so it pulls up my local desktop editor and brings it up for me to use that to edit the Raspberry Pi file, which is very convenient. All right, so if you want to get hold of a Sublime Text or Atom text editor, go back into my website and download one of these. It should work pretty good. Atom is free. Sublime is also free, but you will need to purchase if you need a full-blown editor. I think there's some cost attached to it. But I use one of these two on and off. So anyways, so the reason why I'm editing this file is, let me go back to here, okay? And what I'd like to do, if you go back to my sessions, I'm logged into this session as Pi as a username. And if I want to log in as a root through SSH, root is not allowed to log in through SSH by default. And that's by design, and it's a good thing, right? Because you don't want people to log in from remote hacker stations to log in as root. So by default, Raspberry Pi image does not allow you to log in remotely using root as your user ID. And I can quickly demonstrate that. If you go back to session, let's do another session. Let's do 1.1.1.190. Default is root. Same port. Okay, that. When I try to log in, it brings up the login window, and I'm going to punch in my password for root. But then it'll fail because it doesn't like you to log in as a root ID. Okay, it's just designed that way. So, which is understandable. So I'm going to close this off. I'm going to go back into the Pi session here and pull up my editor. In the sshd_config, there is a key or a setting called permit root login, and by default it's set up to be prohibit password. Okay, I'm going to uncomment that, and I'm going to change this to yes. Okay, and I'm going to save this. Okay, Sublime brings up this window, autosave, do not ask me again. Okay. Oh yeah, you know what, that makes sense. I hope you guys understand this too, because I opened Sublime Text using Pi as my password and it's not letting me write to it, which makes sense. So what I'm going to do is I'm actually going to close this off for now. I'm going to go back here, and I'm going to actually have to do this through nano for now. Nano sshd_config, and then I'm going to look for that permit root login, add yes, and comment out the prohibit password, and I'm going to save this. You know what? I should add sudo. I'm sorry. Sudo. Yeah, continue. Let's do this again. Sudo nano sshd_config. Yes. I'm gonna go in here and look for this guy, change this to yes, and comment this out and save it. Okay, now I've enabled the root login. I'm gonna reboot, or sudo reboot, and we'll give it a minute and we'll be right back. Okay, so it should be rebooted by now. I'm gonna try by pressing R. It'll reconnect me to the Raspberry Pi. Clear that. Let's see now. Let's go back to the Sessions tab here. Let's try to log in as root. Double click. There you go. Now I'm in as root. So let's try this. I'm gonna do follow. Let's see, cd etc. Let's go to SSH, and let's edit now with my default desktop Sublime text for now. Cancel that. Change this to Ruby so I have some coloration. And there it is. I'm gonna see if I can save this. I'm gonna change this to like that and hit save and go here. And I'm gonna close this off so it let me save. Let's go to edit again. Let's see if our save if our change was saved. I bet it is, but let's just confirm. Cancel. Let's go down. There it is. Our change was saved. So our root setup is also working. Fantastic. All right. So now I'm going to work off of the root SSH going forward for the remainder of this part 3. My first step is to make sure I install Nginx. Okay. And apt get install Nginx. Yes. I'll let it finish and I'll be right back. Okay, so the Nginx is installed, which is great. And let's go in here. Nginx gets installed in the etc Nginx folder, so let's go to that. etc Nginx, and there you have it. There is a file called nginx.config, and you usually want to take a backup of it, so I'm just going to make a copy of it. nginx.conf to nginx.conf.ori or original. Okay, that way when you modify your config file and if you need to revert back to the previous or the original version, you have a copy of it. All right, I think this is a very good point in time to do another quick update. Apt get update. And I'm not going to install PHP or Python, because what I want to really show you here is just the basics of a web farm and load balancing functionality. If you want to go install Python or PHP for some advanced web services, feel free to do that later. But for the purposes of this demo and what we are trying to accomplish here, I'm just going to keep it to bare bones Nginx with a default HTML page and show you how the load balancing will work in our new cluster. Okay, so I think this might be a good point for us to stop and take this default image and replicate that to 2 other SD cards, and then we'll start doing the customization for each of the nodes, one for the broker and one for the worker. Okay, with that I'm gonna pause right here and I will show you how to take an image. So before I do that, what I need to do is shut down the Raspberry Pi. Okay, so just do shut down now, and that should shut it down. Okay, so I took that SD card, plugged it into my PC here, and I'm launching that Hdd Raw Copy Tool again. So we'll double click on the target. In this case, the target is our file, so I'll click on that, and we'll select the target file, and let's see where we will store that. We want to select the raw image file, and let's select that name. We're going to create a web farm2 custom image.img file using the custom SD card we just created. All right, so let's go ahead and dump the image to that file, and let's go start. I'll let it run, and I'll be right back when it's done. Okay, so the copying is completed. We now have an image of the custom image we just created from the SD card. So what we're going to do next is take the custom image uh, on the file, and then burn 2 additional SD cards for the cluster, and that'll be our step number 2 here. All right, I'll be right back. Let me close this off. I'll be right back. A quick note, we need to create 2 additional SD cards. My experience has been, and my recommendation is, to select the exact same type of SD cards as the other one is. Same brand, same size, same type would be better. That way, when you take an image, it's a exact replica, a cookie cutter replica of the other SD card's image. Okay, so I've had some issues by mixing and matching. For example, if I took one of these cards and used that as one of my SD cards for this cluster, you know, I've had trouble making those work successfully in the past. So just something for you to keep in mind. In my case, I have 2 exact brand, size, and type of an SD card with me, so I'm just gonna go with these 2 here. All right, I'll be right back. Okay, so I popped in the second SD card. I'm gonna take the raw image file. So let me double click here. I'm gonna select the source. In this case, the source will be the image file we just created, which is approximately 16 gigs, and that makes sense. Let's double click that and continue. Our target will be the SD card number 2, and I'll select that, and we'll just go start. Yes, go ahead and erase that. We'll let it run, and I'll be right back. Okay, so the second SD card is complete. I'm going to repeat the same process for the third SD card, and I think we'll be ready from there to install those SD cards into the cluster and go through the final few steps to see the load balancer work. Okay, so I have the 3 disks SD cards burned right now. This is the broker and worker 1, worker 2. So I'm going to take these to the cluster. What we'll need to figure out is, once we install these on the cluster, we'll have to figure out what the IP addresses are that are assigned to each one of these. And the way we will do that is we'll probably hook up the monitor that we used earlier to each one of the nodes on the cluster, note down the IP addresses, and then go into our SSH terminals and configure them individually. So as of now, each of these SD cards have the exact replica of the custom image we built earlier. We'll have to then configure the broker differently from the 2 workers, and the workers will have a web server running in them, just responding to HTTP calls, and the broker will act as a load balancer between the 2. And so if you go back to our part 1, where I demonstrated the load balancer and the worker nodes, we'll be replicating that behavior in our next steps here. Okay, so I hooked up this monitor to the first node, the broker node,
and I connected up LAN. Okay, so I hooked up this monitor to the first node, the broker node, and I connected up the internet, or rather the LAN connectivity to the internal router to the switch. And then I'm gonna turn this on, and let's see if we can. And then, by the way, I also hooked up the keyboard to the first node there. Hey, by the way, so there we go. We are looking at the broker node up and running, and looks like we are in good shape. So the IP address that was provisioned to the broker is .249, so I'll just make a note of that so we can get to it from our SSH terminal. So that's the broker's IP address, okay, which is good to know. Now I'm gonna switch this over to the second one and then the third one and figure out what their IP addresses are, and I think we should be in good shape. Alright, I'll be right back. Okay, we are now on the node number 2, worker 1, and I hooked up the HDMI cable to it, and we'll log into this one and see what is its IP address. Actually, I can tell its IP address is .220. So I'll make a note of that. I just want to make sure. Let's see if I can log in. Actually, you know what? Here, that's the actual IP address. Yeah, it is 220. I must have gone blind. Okay, .220. So that's good to know. We'll do the same for the last node here and go from there. Okay, its IP address is .241. .241 is our worker number 2, node 3. Alright, I think we are in good shape. So what I'm going to do is basically I'm going to unplug the monitor and the keyboard mouse pad from the cluster and then go into my PC and SSH into the cluster, and I think we are in the last few steps of making this cluster work as a load balancer and web server. Okay, so I'm back on my PC on my terminal tool. I'm going to create a new SSH session to go into our new web FARM-2 cluster, web FARM-2 broker, and let's see, root. Actually, you know what, I need to give it its IP address 1.1.1.1 or 249, I think it was, for the broker. And I'm gonna go into advanced, there's a name somewhere here, bookmark, session name. I'm gonna call this broker, okay, and save that. And there we go, we are connected to our broker here. I'm going to log in as root, and there we go, we are in the broker. Alright, so one of the things we want to do in the broker, I'm going to increase the font size here. One of the things we want to do in the broker is to change our host name. Currently the host name is set to the default host name is web-farm-2, as you can tell from here. But I want to call that web farm-2 broker, right? So to do that, I'm just going to call Raspi-Config tool we used in the first place. Let's go and launch that. I'm going to change the host name to Raspi-Farm-2 broker. Okay. In fact, I'm
let me see if I can save web farm, sorry, web farm-2 broker. Okay, okay that, and I think we are set. I'm gonna just go finish and reboot. So that's the broker. Let's now rather create another session to go into our worker number 1. That's 1.1.1.220. Again, let's try to log in as root. I'm going to change its name to webfarm2 worker 1, worker 1, or number 1, whatever, worker 1. And let's OK that, and it'll try to log in to worker 1. Let's see if we can. Well, I think I know what's going on. We are having trouble connecting to the worker number 1 because the IP address that was originally allocated to it was 220, but now I'm looking at my router on my other screen. My router has assigned it a 228 address. So because I haven't allocated a static internal IP address to the nodes, the router decided to assign a new IP address. So I'm going to go in and I'm going to edit the session and make the change to 228. Again, in real life, you would actually assign a static IP address to these internal static IP addresses to these nodes that are sitting behind the firewall. But we are just demonstrating here. So the allocated IP address for worker number 1 is 228. So let me try. I'm going to close this and close this, and then I'm going to go in there again. There we are. I'm going to log in as root. And there we are in worker number 2, logged in as root. I'm going to go in, again, the same deal, Raspi-Config. And I'm going to change the host name. Let me increase the font here. Change the host name to, what do we call that? We said web farm2-worker 1. Okay, let's do that, and OK it, and finish. Reboot, yes. So we're now rebooting worker number 1. I'm going to create another session for worker number 2. Let's do that. Its IP address has not changed, so we'll just go with 1.1.1.241. And the IP, the username is root, same port. I'm going to change its name to web farm2 dash worker 2. Okay, all right, so OK that, and so there we go. It's letting us in. We'll log in as root, and the password, we'll log in our password. We are in worker number 2. We'll launch Raspi-Config. We'll change its hostname also to reflect web farm2-worker 2. Okay, OK that, finish, reboot, yes. So I think now we have all 3 nodes with the corresponding host names: broker, worker 1, and worker 2. We'll give that a minute to reboot for worker number 2. Let's go into broker, and let's see if she's up and running. Yes, she is. Let's see, ping, let's say google.com. Okay, that's working. Now let's go into, I'm gonna do this one here, follow terminal for broker, and I'm gonna change that folder to Nginx. All right, and there's the Nginx config file here. I'm gonna rename that to I'm gonna save a copy of that. I'm gonna do cp nginx to nginx.original, so we have a copy of it if in case we need to revert back. It's always a good practice to keep a copy of the original config file just in case. So we have that. What I'm going to do is I'm going to configure my broker to be a load balancer. And if you recall, in our part number 1, I said I would create a template file, rather. Sorry, I had a brain fart. A template file, so you guys can download and customize it to do whatever you want to do with it. So let me go to my website, N0AGI.com, and I'm gonna pull it up here. Let's see if I can pull it up here. And if you go to that website, and let me increase the size here, go to web farm cluster and look for this one here, project files section, link to the OneDrive share. Click on that, and that should take you to my OneDrive share, and you can check that and download. I already have a copy of it. It'll download it as a zip file, unzip it, and you'll have the files with you. So I'm going to close that and close that one too. So let me pull up the files in my folder, and here's the downloaded template I was telling you about. I'm gonna open, this is on my local, the one that I just downloaded from my website. I'm gonna open that with Sublime Text. Okay, and here is the broker config file template. Feel free to customize this to whatever you feel is required. I just have some basic cookie cutter settings, and I have the DDoS attack constraints in there, like we described in part number 1. Go take a look at that if you have missed it. And I have commented out sections that are not pertinent here. Okay, so let's start from the top. So basically we are saying user is that's just a default user. You don't need to change that for now. Rest of them, they're just cookie cutter stuff. Don't need to worry about those. Again, these are from my part 1, so go take a look at that part 1 if you have questions on what these are for. To summarize, these are there to mitigate DDoS attacks. Okay, you can actually comment that out for this demonstration, so I'm just gonna go do that. Just comment that out. Okay, I'm not too concerned about DDoS attacks here. What I'm concerned about is the bucket that defines the nodes that will participate in my cluster. So I'm going to give it a name. Let's call this my web farm. I'm just going to call it 2. Okay. And you need to identify the nodes that will be participating here in that cluster as workers. So basically, I have 2 clusters or 2 nodes here in my 2 worker nodes here in my cluster. The first one's IP address is as we looked at earlier, 228, and the second one is 241, I believe, right? So this is worker number 1, and this is worker number 2. Okay, that's worker number 2. All right, so the name of this cluster is my web farm 2. That's just an internal name for Nginx. I'm going to take this one out, and I'm just going to put an underscore, which is just the default name to the server name. I will leave this as is. Now we'll define the location section for this server. I'm going to comment out the DDoS attack sections in there. This is the most important part. I'm going to change this to my bucket name or the cluster name that we defined up here. This one here, okay? We're going to use that name. So basically what we are saying is, hey, if you get a request on your default server, use or forward that request to this cluster, and then Nginx does all the dirty work behind the scenes to do the round robin, as I described in part number 1. Okay, so and this one here, we can actually just comment this one out also, because this is for DDoS attack specific section, so you can comment those out. Again, feel free to use it when you build yours out. I'm just trying to keep this as minimal as I can and yet be able to demonstrate the load balancing features of Nginx, okay, in our new cluster. That's pretty much it. If you were to really simplify, that's pretty much it. And I'm going to save this, and I'm just going to copy this whole thing. Copy that from my local PC here, and then I'm going to go here and I'm going to open that from on my Raspberry Pi, which is this guy here, right? So I'm going to copy all of that, delete, and paste this new one and save it. And then it'll ask you want to save it? Yeah, auto save it, don't ask me again. And I think we should be good. Now what I'm going to do is service Nginx stop. Okay, that stopped. I'm going to restart. Okay, so I think the broker side of the Nginx stuff is completed with these changes. Okay, so I'm just going to close these two, close off Sublime Text. So we are done with the broker. Let's go back to our sessions and let's go open the worker node. I'm going to log in again into the worker number 1. As you can tell, the host name is there. The new host name for worker number 1 is there. I'm going to go and select this follow. Go into etc Nginx. All right. And I'm gonna, same thing, I'm gonna make a copy of it, cp nginx.config to nginxconfig.original. I'm gonna go back into my PC, go into my worker node files that I have downloaded from my website, and that's a worker config file. I'm gonna open that. Okay, let me close this off. And let's walk through that so you guys are aware of the components in it. Again, a lot of these is cookie cutter stuff, so I'm just going to leave that as is, not going to mess with it. The server name here is underscore, which is a default, and the root, we need to worry about this folder here. I'll come to that in a short while. And the rest of it is commented out because of PHP stuff. So if you want to install some PHP and take advantage of that, I have included those sections in there so you can edit and make sure you can take advantage of those sections. But for now, for this demo, we are just going to leave it commented out. Okay, so let's walk through. All of this stuff is cookie cutter stuff, so just leave it as is. Let's focus into the port 80. Server name is default, location root. We need to figure out where our index.html file is going to live. So we need to create a folder. Let's call it my website root folder. Let's copy that. Okay, let's go into the terminal window, and I'm gonna go into root, and let's see, I'm gonna create a folder, mkdir www, just for now, right? Whatever folder, wherever you want to put it, you feel free to do so. And cd www, and I'm gonna create mkdir, paste that, my website root folder. Okay, cd my website root folder. Okay, so I'm gonna go touch index.html. all right, and there it is. I'm gonna open that with my Sublime text. I'm gonna say HTML, and I'm gonna say h1. Let's do h1. This is index.html from worker number 1. All right, and then we're gonna save it. All right, we're gonna save that, and let's see if we can type that thing here, cat index.html. There it is. All right, so the index.html file is in that folder, which is good. Let's go back to our broker. We're gonna close the broker off. Okay, we are back on worker number 1, and I'm gonna close off this index.html file. Now let's focus on the Nginx config file. I'm gonna go to etc, back to Nginx folder. Nope. Okay. What I'm gonna do is, so I made a change to my root folder. It lives in www whack my website folder, right? So that's where the index.html file lives. I can remove the index.php file because in this example we only have an index.html. Okay, I think we are done. We are basically just gonna do a very simple example using the index.html file. Okay, I'm gonna save that, and then I'm gonna copy all of that. Again, we are just making changes to my PC here, to my downloaded file. I'll now have to go into my Nginx folder on my worker 1, open that up, and I'm gonna select it all and paste it, right? And I'm gonna save it. Okay, and we're done. We're done with the worker 1. Okay, so let's see. Cat nginx.conf. There it is. Our file is updated. It's still there. Okay. All right. So we're good. Now what I'm gonna do is restart Nginx on the worker. Service Nginx restart. Okay. So worker number 1 is all done. We can close him off. Let's go to worker number 3, or 2 rather. Okay, now let's pull up worker number 2. There is our worker number 2. I'm going to select the follow terminal folder, cd nginx. Well, let's go to root first. mkdir root www. We need to create that same folder here in our worker number 2, mkdir. paste. There we go. CD ls, there's nothing in there. We're going to create this index.html file, right, like we did with our worker number 1. Touch index.html. All right, so let's open that up. Okay, now what we need to do, we need to basically take that file we created earlier, just copy that whole thing, go into our worker2's index.html file, and wait a minute, I thought we had saved that. Okay, this is from index.html file in worker2 number 2. Okay, it's slightly different from what we had with the worker number 1, but that's all right. Let's save that, and yep, save it, don't ask again. So we got that covered. And what we're gonna do is let's close this off. We are going to take this index Nginx config file and then copy that into the Nginx config file in worker number 2. So let's go into etc Nginx and pull up the Nginx config file here. I need to make a copy of the Nginx file here. cp nginx to nginx.ori. Okay, now let's open up our Nginx config file. Okay, so there it is. I'm going to select it all, delete it, go to my local file, select that, copy, go to my worker number 2's and config file, paste it. Okay, and we are done. So I'm going to save that, close it off, close this off, close off our Sublime, and let's make sure cat nginx config. I think we are good. So now I'm going to restart the service nginx restart. So now our broker is set up, our 2 workers are set up. If everything works as expected, we should see our web page. Let's pull up our web page. I'm gonna go and I'm gonna call 1.1.1. What was the brokers? 249. There we go. That's index 1. That's index 2. There we go. Our load balancer is working. I'm going to hit refresh. F5, 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 F5. Very cool. It's amazing how easy it is to work with Nginx. And agreed, load balancers logic is not really complicated, right? And I built a load balancer for work many years ago in my previous life, and that was a process-based load balancing, and this is a packet-based load balancing. Well, actually, this is not even that. This is just a round robin. The load balancer we have today in this cluster number 2 is a round robin, which is cyclical. So basically, if you pull up, let's pull up our broker number, our broker, and I'm gonna log in here, and let's go to, if you go to our etc Nginx, okay, and follow terminal. I'm gonna go and pull it up here. And if you look at Ruby, okay, if you look at our this one here in our broker, that's just a round robin logic. So that nothing fancy going on with this load balancing logic inside Nginx. But even with that said, there's quite a bit of work happening behind the scenes inside of Nginx to make it work. So that's very exciting. All right. So the worker. So in our example here, let me do that. So we got. So we got our. Here, let me move it to the side like that. So if I do F5, worker number 1, F5, worker number 2. So right now I'm in the broker. Let's switch over to broker number 2, or rather worker number 2, and I'm going to stop service Nginx stop. Now worker number 2 is practically dead from the perspective of Nginx. So if I do F5 now, worker number 1, because worker number 1 is still up, and I'm going to hit F5 again, F5 again, F5 again. So it goes to worker number 1 and not to worker number 2 because worker number 2 is dead. I'm going to start worker number 2. And when you start the service, it goes through some instantiation process. We'll give it a quick few seconds here. And let's go back to our browser. Hit F5. Let's give another second. F5. F5. There you go. Worker number 2 is up. Worker number 1, worker number 2. All right, let's go to worker number 1. And let's stop its Nginx. So worker number 1 is stopped. Let's go into a browser, F5, F5, refresh, refresh, refresh. It keeps going to worker number 2 because number 1 is dead. All right, so let's restart. Let's give it a few seconds for worker number to instantiate itself. And let's hit F5, refresh, refresh. There you go, worker number 1, worker number 2. 1, 2, 1, 2. All right, thanks for watching. Again, this has been an exciting journey for me, myself, to show you guys how to build a Raspberry Pi web farm number 2 cluster from start to finish, from inception to completion. So we looked at how to build a hardware component of it, and we looked at how to build a software component of it. There are several things you can do from this point on. You can make your web servers practical in the sense you can install PHP into it, you can install Python into it, and have web services running into it and see it work. So I'm going to show you guys a quick view of what runs in my cluster number 1. So if you go to call.n0agi.com, I showed this to you in my part number 1. So that's call sign lookup service that's running on the web farm number 1, and that's another view of it. That's one service. Here's another one, cubes.n0agi.com. This provides a real-time cube data for cbridge and DMR repeater network for both user cube and repeaters cube. That's one. There's the other one called dash.mndmr.net. This is a far more comprehensive service that runs on the Raspberry Pi cluster number 1. This is a real-time analytics dashboard view. It talks about how many repeaters are using the network and what kind, how many users are using, how many minutes, what is the data loss packet loss or whatever be it. There's a lot of data in this web service, and all of that stuff runs on my Raspberry Pi cluster number 1. And if you can imagine, it's a fairly decent number crunching service. This runs in real time up to the minute, and portions of this run every 10 seconds. So there's a refresh of every 10 seconds in here. All of this runs on Ajax. It uses Google Analytics. It uses Python in the backend. It uses PHP. It uses Bash scripting in the backend. And there's a lot of stuff. There's also cron tabs, cron jobs running in the nightly process. There's a lot of stuff happening behind the scenes of this particular dashboard. And just to showcase as an example what can be accomplished in real life instead of a Raspberry Pi farm cluster. Okay, with that, thank you so much for watching, and I would love to see what you guys will do with this idea and carrying it to the next steps. There's a lot of opportunity there, so please feel free to share your projects and what you will do with your Raspberry Pi clusters. I'm very interested in learning from your experiences as well. We are all in it together. We are all learning from each other. So if there's anything you would like to share, would love to hear, and will be a great experience for me myself. Thanks again. We'll talk soon.